Hi, welcome to our lecture videos about mathematics. In this video, we will talk about the nature of mathematics, patterns and numbers in nature and the world. What is the nature of mathematics? Mathematics is the study of pattern and structure. Mathematics is fundamental to physical and biological sciences, engineering, and information technology, to economics, and increasingly to the social studies. This field of knowledge relies on mathematics. There are tendencies that they cannot exist alone without the nature of mathematics, which studies pattern. Mathematics is a useful way to think about nature and the world because mathematics is the tool to quantify, organize, and control our world, predict phenomena, and make our life easier for us. Now, what is mathematics? As a practical matter, mathematics is a science of pattern and order. Now, what is mathematics? As a practical matter, mathematics is a science of pattern and order. Its domain is not molecules or cells, but numbers, chance, form, algorithms, and chains. Mathematics, as a science of abstract objects, relies on logic rather than on observation as its standard of truth, yet employs observation, simulation, and even experimentation as means of discovering truth. The patterns and numbers in nature and world. Mathematics reveals hidden patterns that help us understand the world around us and in our life. And mathematics helps make sense of these patterns and occurrences. Patterns in nature are visible regularities of form found in the natural world. These patterns recur in different contexts and can be sometimes be modeled mathematically. So later, we will discover what are these hidden patterns we can see in our nature and in the world. These natural patterns include symmetries, trees, spirals, meanders, waves, foams, tessellations, cracks, and stripes. The early Greek philosophers studied pattern with Plato, Pythagoras, and Empedocles attempting to explain order in nature. The modern understanding of visible patterns developed gradually over time. So we have to give credits to these three philosophers, Greek philosophers, who started studying patterns. They are Plato, Pythagoras, and Empedocles. We can see patterns in the sky. Look at these constellations. We can see patterns can be observed even in stars which move in circles across the sky each day. So it is very nice to look at these constellations if the clouds are clear during nighttime. The weather season cycle each year. All snowflakes contains six-fold symmetry, which no two are exactly the same. We don't have snowflakes here in the Philippines, but if given the chance that you would be able to see snowflakes in the future, these are examples of the snowflakes and all of them are unique, but they have six-fold symmetry. If we are going to look at our weather, other countries have four seasons: the summer, spring, winter, and autumn. Here in the Philippines, we only have rainy season and summer season. Patterns can be seen in a variety of fish. These animals with fish stripes and spots attest to mathematical regularities in biological growth and form. Look at these species of fish. They are very nice to look at, very colorful. So they are one of the beauties of patterns. Zebras, tigers, cats, and snakes are covered in patterns of stripes. Leopards and hyenas are covered in patterns of spots, and giraffes are covered in patterns of blotches. So there are patterns we can see in different skins of animals. Natural patterns like the intricate wave across the oceans, sand dunes on deserts, formation of typhoon, water drop with ripple, and others. This serves as clues to the rules that govern the flow of water, sand, and air. So there are patterns that we can see out of these things from the waves, from sand dunes, from hurricanes, and even from a water droplet. There are patterns that we can observe. Other patterns in nature can also be seen in the ball of mackerel, the V formation of geese in the sky, and the tornado of starling. So look at these images. The ball of mackerel is very nice to look at, the V shape of geese. Of course, tornado is one of the disasters we don't want to experience, but there are patterns that we can see out of this tornado. What does mathematics play in pattern and numbers in nature? Mathematics helps organize patterns and regularities in our world. Mathematics helps predict the behavior of nature and phenomena in the world. So we are very thankful to this pattern of mathematics because these are the benefits of it. Mathematics helps control nature and occurrences in the world for our own ends, and mathematics has numerous applications in the world, making it indispensable. Now, let us discuss what are the types of pattern that we can see in nature. The first pattern is symmetry pattern. Symmetry is when different sides of something are alike. These reflections may be mirror images with only two sides, like two sides of our bodies. They may be symmetrical on several sides, like the inside of an apple sliced in half, or they might be symmetrical on all sides, like the different face of a cube. We understand symmetry quite well in living organisms because it is a function of their environment. In order to balance, we need to have symmetrical body structure so that we don't fall over from imbalanced weight. What we don't understand very well is symmetry in non-living things. There are types of symmetry we experience, and the first one is reflection, which is also known as line symmetry or bilateral symmetry. It means that one half of the image is the mirror of the other half. If we are going to look at this tiger by dropping an imaginary line here, we can see that what's on the left side mirrors on the right side. If you are going to look at this image, which was pictured perfectly at the right time to show symmetry, look at this body. It shows symmetry. What's on the left side can be seen on the right side, as well as the face of this cute cat and this beautiful butterfly shows reflection, line, or bilateral symmetry. The next type of symmetry that we are going to discuss is rotation symmetry. It means that object or image be turned around at a certain point and match itself from a number of items. So from rotation symmetry, from the root word rotate, so we are going to turn around the objects. So let us focus on this five petal flower. So there are five petals. If there is an imaginary line here, you can see there are 2.5 petals on the left side and 2.5 petals on the right side. And if we are going to rotate this flower, still we can observe the same symmetry on this singular petal. And if we are going to rotate this four petal flower, we can see rotation symmetry, as well as with this five-fold symmetry or five petal flowers, these three petal flowers as well, including this starfish with five-fold symmetry, and look at this snowflake with six-fold symmetry. Next type of symmetry is the radial symmetry, similar to rotation symmetry, but here's the difference. An object or shape with radial symmetry does not move in order to show symmetry. So we are not going to rotate the object to show symmetry. We just have to drop a vertical line test or a horizontal line test or a diagonal line test, and it shows symmetry with this plus sign, that is also the same with this orange lines. And that is also the same with this water splash. And that is also the same with this water splash that shows radial symmetry. And also with this, and that is also the same with this object. Another type of symmetry is translation symmetry. Results from moving a figure a certain distance in a certain direction, also called translating, or by moving by a vector with length and direction. Now, let us try to observe this original figure here, the triangle. And there is an image here that is moved on the upper right direction. And we can see the symmetry on the upper right direction. And let us focus on this honeycomb on the upper right, on the upper left, and lower right. We can see translation symmetry. That is also the same with this pine cone. The second type of pattern that we usually see in nature is called fractals pattern. Fractals are the never-ending patterns that repeat indefinitely as the pattern is iterated on an indefinitely smaller scale. Infinite iteration is not possible in nature, so all fractal patterns are only approximate. We see this type of patterns in trees, rivers, mountains, shells, clouds, leaves, lightning, and many more. So one example of fractal pattern can be seen in ferns. Ferns are a common example of a self-similar set, meaning their pattern can be mathematically generated and reproduced at any magnification or reduction. The mathematical formula that describes ferns named after Michael Barnsley, in other words, random numbers generated over and over using Barnsley fern formula, ultimately produce a unique fern-shaped object. So let us look at the leaves of this fern. It is repeating again and again until to this smaller area. Another example is the cauliflower, which is the ultimate fractal vegetable. Its pattern is the natural representation of Fibonacci or golden spiral, a logarithmic spiral where every quarter turn is a farther from the origin by the factor of phi or factor of phi, the golden ratio. Now, let us look at this cauliflower. Now, there is the biggest branch, and we have here a smaller branch, and there are new branches. Now, we can see, so the pattern is repeating and again by creating new branches. Now, let us look at this top view of cauliflower. As you can see, there are illustrations. Now, it shows the Fibonacci sequence or the golden spiral. It shows the golden spiral. And look at this cauliflower. The patterns are similar. The patterns are repeating into smaller scales up to this point. Another example of fractal is the lightning. The path lightning takes is formed step by step as it moves towards the ground, turning into air into plasma. Look at these scary lightnings. No? There are patterns. Now, this is the biggest lightning, and there are cracks. We can see that creating another cracks as well, smaller cracks. So that is fractal. A fractal cloud pattern is interrupted by a series of diagonal groves. Cloud streets form when low-lying clouds are interrupted by an object such as an island. Similar patterns occur in the wind flow downstream of airplane wings. Look at these beautiful cloud formations that shows repeated patterns. And this is an example of fractal pattern that we can see in nature. Look at these mountains and rivers. So this is in Norway. So we can see the formation of mountain ranges and rivers. And look at this Nautilus shell. And look at these waves. This is the biggest wave, and there are smaller waves we can see within. And look at these trees. This is the biggest branch, and there are smaller twigs. And up to the smallest part of the tree, the pattern repeats again and again. The next type of pattern that we usually see in nature are spiral patterns. Spirals are another common pattern in nature that we see more often in living things. A logarithmic spiral curve is one that gets smaller as it goes, which often appears in nature. It was first described by René Descartes and later investigated by Jacob Bernoulli. A spiral is a curved pattern that focuses on a center point and a series of circular shapes that revolve around it. Think of the horns of a ship, the shell of a nautilus, and the placement of leaves around the stem. We can also see this pattern in hurricanes, galaxies, and some seashells, pine cones, and even pineapples. Now look at this spiral galaxy and look at this horn of this goat and look at this aloe vera, in spiral shape, and look at these vine tendrils. I believe this is asayote. And look at this whirlpool. We can see this in rivers, even in oceans. And we have here pine cones. So it is in spiral. So those are the three major patterns that we can see in nature. We have the spiral, we have the fractals, and we have here the spiral. There are other patterns that we can see in nature. An example for this are foams. Foams are typically referred to us as a massive bubble, but other types of foams can be seen within the patterns of certain animal species, such as leopard, giraffe, and tortoise. So look at these foams that is formed after the waves in the sea. And look at this back of the tortoise. There are foams we can see, and look at this skin of the leopard. Look at this giraffe. Another pattern that we can see in nature is called tessellations. Tessellations are repeating tiles over a surface commonly seen in reptiles like snakes and alligators. So there are tiles that we can see in this snake and at the back of this alligator and at the back of this turtle. And look at this pineapple. So there are tiles. Look at this pineapple. There are tiles that we can see. And look at this honey. There are also tiles that we can see in this honeycomb. The other patterns that we can see in nature are cracks. Cracks are linear openings that form in material to resist stress. When a material fails in all directions, it results in cracks. These patterns created reveal if the material is elastic or not. Look at these cracks that we can see in our lands. So this is very common in our place, especially if there is a long period of no rains. And we can see this in wood. So there are cracks. And in stones as well, there are cracks we can observe. Look at this tree. I believe this is a mangium tree. There are cracks we can observe. Look at this dry land. There are cracks. And look at this big crack that we can see in this particular picture. Another pattern that we can see in nature are stripes. The stripe pattern is evolutionary as it increases the chance of survival through camouflage. It is most commonly known in zebras, but other species contain stripes, even butterflies. Look at these stripes of zebras. It's very nice. And look at this fish. And look at this butterfly. Look at these plants, no, to our plantito and plantitas out there, and look at these rock formations which show stripes. Other patterns we can see in nature are menders. A mender is one of a series of regular sinuous curves in the channel of a river or other water course. The result of this coupled erosion and sedimentation is the formation of sinuous cores as a channel migrates back and forth across the axis of a food plane. So look at this river formation. So it's like a snake that curves again and again. So look at this formation of rivers. So these are called menders. And thank you so much for staying up until this time. And if there are patterns that I failed to mention in this video, please comment it below. And that would be all. Thank you so much. Bye-bye.